last presentation of this training session, and this one is on the multi-factor authentication of ARCADIAN-IoT, which in fact is a component that joins the factors that we discussed before, right? The decentralized identifiers, the biometrics, and the network-based authentication. So the agenda for this presentation is why and how we should use multi-factor authentication. Then we will go through the multi-factor authentication of the ARCADIAN-IoT, which in fact focuses on establishing the security and trust in management of objects and persons identification. So moving to the multi-factor authentication, I'm sorry, because I cannot see all the screen, but yeah. So why is the authentication critical, and its reliability, why the reliability of authentication is critical? First of all, as you noticed, right, the authentication aims to validate the identity of a person or a device, and through that allow the access to a particular service or data. Impersonation is one of the threats for the identity of a person or a device, and it's critical in fact. And that, let's consider why. If in the use of bank services by bank clients or bank employees, an impersonation could grant to an unauthorized person or device, or in this case person, the access to bank information and the ability to do money transfers. Again, the impersonation and the control of a laptop or a smartphone could grant access to private data like contacts, photos, emails, and many other private data. In the control of a security camera at home, for instance, or at the office, it would allow to have access, unauthorized access to private habits or to private data in use by employees. Again, an impersonation attack to the identity of a person that is owner of a smart car, in this case, would grant it access to sensitive information like location and destination. So impersonation is a very critical security threat. Moving to the most used authentication method, in fact, it is username and password. And in fact, the user expects to use or to apply username and password to authenticate. So in terms of usability, in a first glance, the person expects to authenticate with the username and password. However, the average person owns 25 online accounts, and only 50% of the persons have different passwords for each password, because passwords are hard to remember, and in terms of usability, this doesn't go well with what I said before. But in fact, persons expect to use username and password, even though that they repeat the same password in several online accounts. It's also common that persons use very simple passwords like name or date of birth, which is quite insecure. And in fact, all of these practices that are not perfect allow that brute force attacks are quite effective, even using available tools online, tools that are available online to hack the passwords. So the use of the passwords is in fact not a best practice in this case, right? And in the IoT case, the number one of the most common security risks is exactly the use of weak, guessable, or hard-coded passwords, according to OWASP. So this is exactly the first or the most common security risk. There are quite a lot of other security risks. That one is the first. And the 10th is the lack of physical hardening. And I'm mentioning this because in ARCADIAN-IoT, one of the factors is exactly using the SIM, which is a way of physical hardening of the credentials of the person. There are several sources that state that due to a variety of security concerns, it's well accepted that a single factor authentication cannot offer effective security. And that's why two-factor authentication processes are studied, are being applied nowadays, in fact. And it increases the security by combining something that the person has with something that the person knows and with a characteristic of the person. So in this case, even if we use a password, which could be something that the person knows, even if that password is compromised, a second factor ensures the security of the service or of the data. So two-factor authentication already increases the security of the private data or the private services. Multi-factor authentication, in its way, it even maximizes further the security. This is an example also from that source. You can use the username password because the user expects to use that, and then you can have one-time password that you can enter in the online service, and this is quite applied. When I said that the public services in Portugal applied the smartphone for entering in their systems, this is the way, right? They send you by SMS a code that you can enter in the system, and then you can use more factors like biometrics or like a pattern or any other mechanism used in the mobile app. And in fact, by summing up all of these factors, we increase the security, even though this can hamper as well a bit the usability of the system. Okay. So moving to the ARCADIAN-IoT multi-factor authentication. So the objectives are, first, to enable security and trust in management of objects identification, and for doing so, we enable two different identification factors for devices, and for persons, we enable three multiple simultaneous identification approaches for persons, and we enable as well mediated mutual authentication between persons and IoT devices. So moving to the high-level architecture of the overall system for persons and for devices. In fact, persons and devices may enter the two factors of authentication that are, in case of devices, the two factors of authentication that apply to devices, which are the decentralized technologies, the self-sovereign identity, and the network credentials. And in the person case, it has the biometrics as well. Then we have the multi-factor authentication that acts as orchestrator of the three authentication factors. And if all of them can be verified, if all of them are verified, the multi-factor authentication issues an ARCADIAN-IoT ID token that can be used by the client, the device, or the person to have the authorization based on its role or based on the privacy settings that the person has defined in a different component. The results of the multi-factor authentication go as well to a device behavior monitoring, exactly to face any security threat. So this is exactly what I said regarding the components that exist in ARCADIAN-IoT that enforce the authorization role and privacy-based authorization. We have the self-aware data privacy, and the device behavior monitoring allows exactly to detect threats like brute force attacks through understanding if a given person is doing a lot of attempts of authentication, for instance. Moving a bit further to understand the architecture of the solution, of the multi-factor authentication solution for devices, here you can see that device needs to have at least the SIM or the SIM, it works as well, and an SSI agent. It will trigger the beginning of the service by requesting the component in the core network to issue the identity token, the network identity token, that goes to the solution provider. So the solution provider receives the ARCADIAN-IoT that wants to authenticate and the network ID token, and then it requests to the multi-factor authentication exactly the verification of that device. The multi-factor authentication, considering that in this case it's a device, we will request to the SSI authenticator the verification of the SSI. So in this case, it will be a decentralized identifier. There is a communication established with the SSI agent in the device for verifying exactly the identity of that device. And there will be an answer to the multi-factor authentication. The same will happen to the network authenticator that will receive the network ID token and verify its validity. If both factors are valid, the multi-factor authentication crafts an ARCADIAN-IoT ID token and returns it to the solution provider, which in turn will return the identity token to the device so that it can proceed and access the services that it's entitled to. In ARCADIAN, we have as device communication protocols that we can use according to the needs of the solution providers that are in the consortium. We have HTTP and MQTT. Please don't forget that communication between device and core network is secure. I said this more than once. And as well, according to the needs of the devices of the solution providers, we allow to have JWTs as ID tokens or CWTs, depending on the capacity of the device and on the interest of the solution provider. In what regards the person authentication, it's exactly the same process, but now having the biometrics, which provides biometrics data since the beginning. So now we are talking about a personal device, right? The person is authenticated through its personal device, and the credentials that it provides are credentials that are in the personal device, being the credentials, the ones from the SIM or the ones that are captured on the moment that the person requests to be authenticated. And apart from that, the process is quite similar, right? With the difference that when the flow arrives, the multi-factor authentication, there is also the requests to verify or to validate the biometrics data received to understand if it matches that person biometrics data, and the remaining flow is the same of the device multi-factor authentication. And to close, what we have done as well is to enable mediated mutual authentication between persons and IoT devices. And in this case, I will try to be agnostic to the case, but in fact, it was thought for being demonstrated in a person authentication using biometrics captured by a drone. So the prerequisites for doing this, for doing the person identification with the IoT device, are what we propose to be are that both person and IoT device have already authenticated individually successfully. If the person that is requesting the service, it is the person that is requesting the service that will trigger its identification by the IoT device. And for the identification to start, both the IoT device and the person need to be in the same location at the same time. Otherwise, the process don't even start. In terms of storyline, to do this mediated mutual authentication, what we have is the following. We have a mediator that can be the solution provider, which validates the requesting person and IoT device ARCADIAN-IoT ID tokens. So, as I said, first, both the person and the IoT device must be successfully authenticated using the MFA, the multi-factor authentication. After that, there is the validation of the service data. That mediator validates that the IoT device that was selected to serve that person is the one that is requesting to authenticate, in this case, to authenticate the person. And it validates as well the current time and the location of both. As we said in the prerequisites, they need to be in the same location at the same time. Finally, the biometrics that are captured by the IoT device match the person biometrics. And what I have here is exactly a diagram that tries to show exactly this flow. The person authenticates, it receives an ARCADIAN-IoT ID token, valid. It requests the service says the authentication through the IoT device, in this case a drone. Then the mediator selects a drone for the service. The drone authenticates itself using the MFA. It receives the ID token, it has a valid ID token, and it has the service data that is coherent with the service request. Then the person provides the location and time for the service, for the authentication, and the drone, when it is near the person, ready to start the authentication, provides as well the location and time. And in this moment, the mediator validates the identifications of both the service, that the person was the one requesting that service, and that this IoT device was the one selected for the same service. It validates as well the location and time of both. And at this time, there is the person biometrics validation. The drone, in fact, identifies the person, according to what Julie said a few minutes ago. So at this moment, there is the biometrics validation that is sent to the mediator, which if it is a valid biometrics, it informs the IoT device of the authentication result, and the service can proceed. So there is what we call a mediated mutual authentication in this case. So summing up a bit, why to adopt ARCADIAN-IoT multi-factor authentication? Because it's quite resistant to password-related vulnerabilities like brute force attacks, phishing, credential stuffing, and many others. It is a beyond state-of-the-art authentication solution that maximizes the security, as it's normal in a multi-factor authentication schema. In our case, we join a hardware-based identification factor, that is the one on that is SIM-based. We join the decentralized identifiers, which allow to avoid single trusted entities. And we join as well the beyond state-of-the-art biometrics that was presented by Biometrics before. We also allow to integrate these technologies with other cybersecurity technologies like the behavior monitoring and reputation system for an efficient protection of the overall solution, of the overall IoT solution, with quite reduced human intervention. So we can infer threats like trying of brute force attacks. Even though it's hard to be successful, this may be relevant for understanding the level of compromise of a given device. And that's why we think that ARCADIAN-IoT multi-factor authentication is a very good solution to adopt in IoT scenarios.